Guys, as we pick up and look at the last two examples, as I mentioned yesterday, these don't affect your homework too much, okay? But as we look at 7 and 8, what's different about 7 and 8?
They're not setting equal to 0.
They're what?
They're not setting equal to 0.
Yeah, but not all of our equations have been set equal to 0.
Right.
Is it coefficient in x?
Yeah, it's not just sine of x, is it? Or cosine of x. Whereas if you look at the rest of the page, everything has been x as the variable, right? So cosine of x, sine of x, tangent of x, whatever the case is. And so that's what makes these two different. As I mentioned in homework, I think it only affected 61, so it doesn't show up in homework as a big thing, but we still need to talk about it. And so when we talk about sine of 3x equals 1, my recommendation is that you start off asking yourself, forget the 3x for a moment, and ask yourself, where does sine of x equal 1? So just ignore the 3x and think about what you would say there. Where does sine of x equal 1? So at what angle does sine equal 1?
90.
5/2.
Yes. My brain all of a sudden had a moment. Okay, I'm there. My brain had pi over 4 on the brain. Don't ask. My brain went tangent for a moment, and so I was really confused. I'm there with you. And this goes back, we drew that chart at the top of the page yesterday, didn't we? Okay, so we drew that chart, or not chart, but the unit circle. And so what I'm going to write here is that you just made the statement, when I said sine of what angle equals 1, you said sine of pi over 2 equals 1. Is that a true statement? Sine of pi over 2 equals 1. If you punch in sine of pi over 2 in your calculator, you're going to get sine of pi over 2 equals 1. Now, what do we notice? We have two similar statements here. I have sine of 3x equals 1, and I have sine of pi over 2 equals 1. So at that point, what can we say?
3x.
Right. 3x and pi over 2 are in the same locations in an equivalent statement. So I can make the equation, if you will, that 3x equals pi over 2. Can we solve for x? Yeah, how do I get x by itself?
Divide by 3.
Divide by 3, or since I'm going to be working with a fraction on the other side,
Multiply by the reciprocal.
multiply by the reciprocal of 3, which is 1 over 3. So I'm going to say multiply both sides by 1 over 3. Do the math. 1/3 times 3. X equals what?
5/6.
Pi over 6. There's your answer. Okay. Now, think about it. Does this make sense? If I put pi over 6 back in the original equation, does that make sense? Sine of 3x equals 1. 3 times pi over 6 is pi over 2, isn't it? So x is pi over 6. So you can still look when you have something other than just x in your parentheses, in your variable location. You can still look at the general statement and just pretend it's x, and then go back and grab that other piece. Okay? Let's try 8 in a similar fashion. Now, as we go to look at 8, though, we kind of have a step we need to take in the beginning. If we're going to solve 8, what would you do first? Divide by 2. In other words, we want to get the trig function by itself, yes? So if I divide by 2, I now have the statement cosine of x over 2 is equal to negative square root of 2 over 2?
Yeah.
Okay. if I treat this one like I did the last one, because again, it's cosine of x over 2. So you could ask yourself, cosine of what angle divided by 2 is equal to negative square root of 2 over 2? Or what I would prefer to do, at least in a teaching aspect, is say, okay, where does cosine of just regular x equal negative square root of 2 over 2? So I was just debating how I wanted to teach this. I was taking a moment. So where does cosine equal negative square root of 2 over 2? They're giving answers that are not in quadrant 1, correct? But can you start quadrant 1 to get yourself going if you need to? Okay, or at least that's where my brain goes to anyways. If it's where does cosine equal square root of 2 over 2, what angle do we have to be thinking? We have to be thinking about pi over 4, yes? However, do we want a quadrant 1 answer? No, because this is wanting to know where is it negative. So, all students take calculus. Pi over 4 gets me started, and that's what I want to think. But it's not an answer because I need to know where is cosine negative. Where is cosine negative? Quadrants 2 and 3?
Yes.
So what are the pi over 4 angles in those quadrants? In other words, what is pi over 4 up from the x-axis in quadrant 2? And what is pi over 4 down from the x-axis in quadrant 3? And there are your 3 pi over 4 and 5 pi over 4 answers. Okay? So, where does that happen? Well, that can happen at 3 pi over 4 and at 5 pi over 4, yes? So what do I have to consider here? Right? X over 2 is in the same place as x. What did we decide x was? Three pi over 4 and 5 pi over 4, right? So what's the statement I can write? These two right here. I'm running out of room. X over 2 is going to be equal to both 3 pi over 4 and 5 pi over 4. Does that make sense how I did that?
So then, would you still have to divide those by 2? And then you'd have your answers?
Not divide them by 2.
Multiply by 2.
Right. So since this is x divided by 2, we are multiplying by 2 to solve. Now, since I wrote both pieces in there, realize you're multiplying both pieces by 2, yes? I could have written them as two separate equations. I was just trying to be time saving, I guess. I guess that's not really proper math to write a double equation like that, but on the flip side, I think you know what I mean. Maybe I'm confusing. Maybe I shouldn't. Okay, so we end up 2 times x over 2 just becomes x. 3 pi over 4 times 2 is going to become 6 pi over 4,
3 pi over 2.
which is 3 pi over 2. 5 pi over 4 times 2,
10 pi over
10 pi over 4,
5 pi over 2.
5 pi over 2. Now, you can do a visual check here and think about, does this make sense? If I take 3 pi over 2 and I put it back into the original equation, or actually, I'm going to use this one. The cosine of x divided by 2. So 3 pi over 2 divided by 2 Well, 3 pi over 2 divided by 2 is going to be 3 pi over 4. And cosine of 3 pi over 4 would equal negative square root of 2 over 2. Okay? So that's the easiest way I can teach these. I'm not going to say there's not other ways to think about them, but when you have something in the variable position other than x, you have to think it a little differently. Okay? Now, the homework that you guys worked on last night was page 404, 51 to 62. I just wrote on there on intervals 0 to 2 pi, and that's just saying what I've already taught in class, that you're just going once around the circle, right? I don't need to know that, okay, well, if 3 pi over 2 is an answer, then when I go around the next time, it's going to be this. When I go around the next time, it's going to be this. Because we could give answers all day, and we don't want to do that. So, okay?